Hello students, welcome to the class Sankalp Learning. So this is the last session on electrochemistry. So we'll be discussing some of the important concepts here also, that is regarding the batteries and bodu, athwa what are the types of batteries and where we'll be using them. All these things we'll be discussing here. So let's get started. So in the previous class, we have discussed regarding the first law of electrolysis, adu Faraday's law anta ಹೇಳ್ತೀವಿ. So Faraday's law ಅಲ್ಲಿ we have two laws in order to explain electrolysis. ಹೇಗಾಗತ್ತೆ, what actually happens, how much amount of the substance or the metal gets deposited or in the process during the process of electrolysis on cathode. ಇದೆಲ್ಲ ಹೇಳಲಿಕ್ಕೆ Faraday, he gave two laws. Yes, in fact Faraday ನಾನು ಹೇಳಿದ್ದೆ last class. Faraday was the first person to speak about electrolysis quantitatively. Quantitative concepts of electrolysis ಹೇಳಿದ್ಯಾರು Faraday. So he put forward two laws and which were called as Faraday's laws of electrolysis. So Faraday's law of electrolysis, we have seen it. Okay, just I am recalling so that if we are solving any numericals, it will help us. And after completing this, I will give some of the concepts ಮೇಲೆ numericals solve ಮಾಡಲಿಕ್ಕೆ help ಮಾಡ್ತೀನಿ. Okay, let us see how we can solve them. Fine. So first law of electrolysis says that the amount of chemical substance which occurs at an electrode or at any electrode ಅನ್ನೋದು ಬೇಡ, specifically what we will say at cathode. ಯಾಕಂತಂದ್ರೆ anode ಲಿಂದ metal solution ಅಲ್ಲಿ electrolyte ಅಲ್ಲಿ ಬಂದು from that solution in the form of ion, it is going at cathode, taking the electron there. Fine. So at any electrode during electrolysis, by the current, by the potential which is being applied, is directly proportional to the quantity of electricity passed. Andre ಎಷ್ಟು amount of metal is getting deposited on the cathode, ಹೆಂಗೆ ಹೇಳ್ತೀವಿ, ನಾವು ಎಷ್ಟು current pass ಮಾಡ್ತೀವಿ ಅಷ್ಟು amount of metal gets deposited. So Faraday ಅವರು ಹೇಳಿದಿದ್ದನ್ನ. So he put forward a law here and he gave the mathematical expression for that. You can see here W is directly proportional to Q anta andru. So W is directly proportional to Q. So what does W stand here? W stands for the mass of the chemical substance which is getting deposited on the cathode. Directly proportional to Q. Q andre enu? Q is nothing but charge. Okay. So and you know that Q is what? Q is I into T. That's what written here. So W is directly proportional to I into T. Remove the proportionality sign, introduce a constant, and the constant introduced here is Z. So W is equal to Z into I into T, where Q is given in coulombs, that is the unit for charge. Current to the unit enu, current to the unit ampere, and time to the unit banbitu second. So where W is mass of a chemical substance, Z is a constant known as electrochemical equivalence, which is abbreviated as ECE. When current of 1 ampere, electrochemical equivalent andre enu? If you pass a current of 1 ampere for 1 second, how much charge you are passing? All should be in unity. So current of 1 ampere per second, 1 coulomb of charge agate. So 1 coulomb of charge flows through the solution or a molten state of electrolyte. Mass of substance deposited or liberated is called electrochemical equivalent. That is yakandre, if you take, see, this is my formula, Z into IT. If I pass 1 ampere of current for 1 second, so these two will be 1. Yes, 1 coulomb of charge aitidu. So Z into 1 is what? Z into 1 into 1 is Z, it is Z. Therefore W is equal to Z. Is that right? So 1 coulomb of what this is electrochemical equivalent. It is equal to what? It is equal to mass of the substance deposited when you are passing 1 ampere of current for 1 second. Okay. So charge on 1 mole of electron, yeshtu? It is 1 Faraday. 1 Faraday. Idana we have already done it also. 1 Faraday is equal to how much? Heng kan hiditivi heli? 1 Faraday andre it is 1 mole andaga. See, 1 electron the charge eshtu? The charge on 1 electron, I'll write it here. You can see the charge on 1 electron is 1.6 into 10 raised to minus 19 coulombs. This is the charge on 1 electron. But when we are talking about here, when we are saying charge on 1 mole of electrons. Charge on 1 mole of electrons. So 1 mole of electrons, what is 1 mole equal to? 1 mole is nothing but 6.022 into 10 raised to 23 into the charge of 1 electron. 1.6 into 10 raised to minus 19. 1.6 towali, or to be more specific, take it as 1.6021. Doesn't matter. You will get the answer 96,487. ನಾನು ನೆನಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ ಏನ್ ಮಾಡ್ತೀನಿ, ಐ ವಿಲ್ ನಾಟ್ ಸೇ ಇಟ್ as 96,487. No, 96487. Remember this number. This is nothing but this is 1 Faraday. ಅದಕ್ಕೆ ಲಾಸ್ಟ್ ಟೈಮ್ ವೆನ್ ವಿ ವರ್ ಯೂಸಿಂಗ್ ಇಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೆಲ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ ವಿ ವರ್ ಯೂಸಿಂಗ್ ದಿಸ್ ಟರ್ಮ್ ಅಲ್ಲ, NF ನರ್ಸ್ಟ್ ಇಕ್ವೇಶನ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಫ್ ಎಷ್ಟು ಹೇಳಿದ್ವಿ ನಾನು, 96,487. ನಾನು ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ ನಿಮಗೆ. ವಿಲ್ ಬಿ ಡಿಸ್ಕಸಿಂಗ್ ಇಟ್ ಹಿಯರ್ ಇನ್ ಫರ್ದರ್ ಟಾಪಿಕ್ ಎಂಡ್ ಬಂದಾಗ ಐ ವಿಲ್ ಡಿಸ್ಕಸ್ ಇಟ್. ವಾಟ್ ಈಸ್ ದಿಸ್ ವ್ಯಾಲ್ಯೂ? ಯು ಅಂಡರ್ಸ್ಟುಡ್. 1 Faraday is equal to how much? 1 Faraday is equal to 96,487 coulombs. Yes, approximation ಮಾಡ್ಬಿಟ್ಟು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ, ಸಾರಿ, while solving the numericals we take it as 96,500 coulombs. Okay, so but if they have given an approximate value ಅಂತ ಕೊಟ್ಟು ನಿಮಗೆ numerical ಕೊಟ್ಟಿದ್ರೆ take this. Otherwise, if you are solving, do it with this only. You will get the accurate answer. Fine. So here they have given an example. You can see Al plus 3, it is gaining 3 electrons and it is becoming Al solid. So 1 mole of Al plus 3, how many Faradays is required here? How many electrons? NF. So how many electrons? 3 electrons. So 3 Faraday. 1 mole ಅಂತಂದ್ರೆ ಎಷ್ಟು grams of aluminum ಹೇಳಿ? You have studied about mole concept in class 11. So 1 mole ಅಂದಾಗ 6.022 into 10 raised to 23 Avogadro number of molecules. 1 mole ಅಂದಾಗ molar mass of a substance ಅನ್ಬೋದು. 1 mole ಅಂದಾಗ atomic mass of the element ಅನ್ಬೋದು. So it is 27 grams of aluminum. So 3 Faraday ಅಂದಾಗ you approximate it. They have approximated 96,500 into 3 ಮಾಡಿ. That much charge is required to form 1 mole or 27 grams of aluminum. Yes. So for 1 coulomb charge, how much? ಅದನ್ನ substitute ಮಾಡಿ, simplify ಮಾಡಿ, you will get the answer. Is that clear? So this is all about the Faraday's first law of electrolysis. So it is directly proportional to current. ಹೆಂಗ್ ನೀವು current ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀರಿ, or with the time as you go on increasing the current, what happens? The amount of substance getting deposited also increases, right? Fine. So here is another example. You can see same example which we have discussed, right? So a solution of CuSO4 is electrolyzed for 10 minutes. They have given the time for 10 minutes with a current of 1.5 ampere. What is the mass of copper deposited at cathode? Atomic mass of copper kottidara 63.5. So I ಎಷ್ಟಿದೆ? I is my 1.5 ampere. T is 10 minutes. Have to be converted into seconds. Correct? 600. So charge ಕಂಡಿಡಿರಿ, I into T, you will get so much. So copper from copper sulfate solution. So reaction is here. Cu plus 2 state alli ide. It will take 2 electrons. So how many Faradays of charge anti 2F, and 1 mole is equal to 63.5 grams of copper. Fine. So 2F solve madi. So 2F is nothing but 2 into 96,500 coulombs of charge deposits, 63.5 grams. But they have said here, how much is my charge? 900 coulombs of charge iddaga how much mass is deposited? Substitute, solve, this much answer you will get. So the answer is 0.2961 grams of copper is deposited when you are passing a current of 1.5 ampere for 10 minutes. Clear with this? So like this we'll be solving many examples further. Fine. Second law of electrolysis ಏನ್ ಹೇಳುತ್ತೆ? Second law, last session itself we have seen, when same quantity of electricity is passed between the two cells, different electrolytes adava, we have taken different electrodes in those particular electrolytes and ಬೇರೆ containers ತಗೊಂಡಿದ್ದೀನಿ. Yesterday's class, last class we had seen I had taken only 2 containers. Here we have 3 containers. So if you are passing same amount of current, see, entire circuit is linked to, it is connected to one battery. Potential difference is only same. So if you are passing same electricity, same quantity of electricity through different electrolytes, this is Ag rods dipped in Ag silver nitrate, this is copper rods dipped in copper nitrate, this is aluminum rods dipped copper sulfate, aluminum rods dipped in aluminum nitrate. In such case, and you have connected them in series, the amount of substances deposited at electrodes are directly proportional to their equivalent weights, are directly proportional to their chemical equivalent weights. And you know, chemical equivalent weight hang kandiditiv now. Chemical equivalent is nothing but atomic number divided by valency factor. valency factor here. If aluminum plus 3 is there, it will take 3 electrons to form Al. So valency factor H2, it is 3. Yes. So this is chemical equivalence. So mass of a substance A by mass of substance B, Wa by Wb is equal to how much? Equivalent mass of A by equivalent mass of B. So like this, we will go on solving. And this is what? This is my Faraday's second law of electrolysis. Faraday's second law of electrolysis. Hope both the laws are clear. Yes, I hope there is no doubt here. Fine. Then we have numericals for practice. We'll see them one by one later. Let us now try to understand what are batteries. Okay. So batteries andaga enu, they are combination of cells. Now represent martivala battery na. How do we represent battery? Tell me. We represent, this is my cell. Longer line represents positive terminal, shorter line represents negative terminal. So this is the representation for a cell. If you want to represent battery, it is being represented like this. So this is a battery with 2 cells. You have a battery with 3 cells, right? Yes or no? So this is the representation for batteries. Now we need to understand what is the construction of these batteries and what are the working and application. We will see them one by one. Is that clear up to here? Fine. So batteries are the source of electrical energy which may have more number of cells connected in series. A good quality battery should be reasonably light, compact, and its voltage should not vary appreciably during its use. So yaudukunu yaude vastu idre how do you determine the quality andaga we see the usage on that basis we speak about the quality of that particular battery. Yes or no? So see, similarly here it should be reasonably light, compact irbeku, amele adar voltage it should not vary when you are using it. Fine. And in this batteries we have types. So there are 2 types. One is primary batteries and another one is secondary batteries. So what are primary batteries? So primary batteries athwa primary cells no antiv now kelomme. What do they? The reaction occurs only once in these primary batteries. Reaction in what chemicals will be using in batteries alla ನೀವು ಚಿಕ್ಕ batteries use ಮಾಡ್ತೀರಿ to toys ಅಲ್ಲಿ ಇರತಕ್ಕಂತ battery ಆಗಿರಬಹುದು, ಕಾರ್ ಅಲ್ಲಿ ನೀವು ಫಿಕ್ಸ್ ಮಾಡ್ತಿರಲ್ಲ ಬ್ಯಾಟ್ರೀಸ್, ಆದ ಬ್ಯಾಟ್ರಿ ಆಗಿರ್ಬೋದು, ಆರ್ ಯು ಕ್ಯಾನ್ ಸೇ ಬಟ್ ನವಡೇಸ್ ರಿಚಾರ್ಜಬಲ್ ಕಾರ್ಸ್ ಟಾಯ್ಸ್ ನು ಬಂದಿದಾವ. ಐ ಆಮ್ ನಾಟ್ ಸ್ಪೀಕಿಂಗ್ ಅಬೌಟ್ ದಟ್ ಕಮ್ಸ್ ಅಂಡರ್ ಸೆಕೆಂಡರಿ ಬ್ಯಾಟ್ರೀಸ್. ಅರ್ಲಿಯರ್ ಯು ಹ್ಯಾಡ್ ಯು ಪುಟ್ 2 cells and immediately we used to play with that. ಆಮೇಲೆ ಸ್ವಲ್ಪ ಹೊತ್ತಾದ್ಮೇಲೆ ಏನಾಗ್ಬಿಡ್ತಿತ್ತು, ಆ ಸೆಲ್ ಡೆಡ್ ಆಗ್ತದೆ. ಇವನ್ ಕ್ಲಾಕ್ಸ್ ಆಲ್ಸೋ ವಿ ಯೂಸ್ ದ ಬ್ಯಾಟ್ರೀಸ್. ಸೆಲ್ಸ್ yes or no? ಸೊ ಅವಕ್ ನಾವ್ ಏನಂತೀವಿ, ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಪ್ರೈಮರಿ ಬ್ಯಾಟ್ರೀಸ್. ಅದ್ರೊಳಗೆ ಮೋರ್ ದನ್ 1 cells ಇರ್ತಾವ. ಪ್ರೈಮರಿ ಬ್ಯಾಟ್ರೀಸ್ ಏನು, ಅದರಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಒಂದೇ ಇಟ್ ಆಕರ್ಸ್ ಓನ್ಲಿ ಒನ್ಸ್ and after use over a period of time it becomes dead and cannot be reused again. Examples are dry cell, which you also call it as Leclanche cell. Amele innondu very better version of dry cell anbodu, that is the mercury cell. Fine. And then you have secondary batteries. What are these secondary batteries? These are the secondary batteries can be used again and again. Andre you supply electric current to it, you can recharge it back. Heng now cell olag best example is your mobile. You take mobile, battery low aitu, you put it for charging. After 1 hour again it becomes 100%, so you can use it again and again. Yes, so that is secondary battery. Which can be recharged, which can be used again and again. So secondary battery cells, in secondary cells, after its use can be recharged by passing current through it in opposite direction so that it can be reused again. A good secondary cell should have large number of discharging and charging cycles. We'll see it one by one now. Ella examples in a detail agi study madbekadre we'll see what are these actually how do we, what is the construction made there, how it is applications yenappa adre. Examples of secondary batteries are lead storage battery, nickel cadmium storage cell anta barutte, nickel cadmium storage cell. So let us take primary cells one first. So primary batteries athwa primary cells ಏನ್ ಹೇಳ್ತಪ್ಪ, primary cells tell us that it is used only once. Reaction ಒಂದೇ ಸರ್ತಿ ಆಗತ್ತಾ, ಒಮ್ಮೆ reaction ಆಯ್ತು, you cannot reuse it again and again. So this is my primary battery or primary cell. So most familiar type of a primary cell is my dry cell, and this is the picture what you are seeing. This is the picture for dry cell. Can you see here? Yes, all the whatever things are being used there, it is being labeled here. I'll explain it, what it is, what is primary cell or what is dry cell now. Okay, so let us start with dry cell. Fine. So which this is a very compact of Leclanche cell. It is known after the discovery Leclanche. This person's name is given here. Dry cell ಅನ್ಬೋದು, ಕೆಲವೊಮ್ಮೆ ಡ್ರೈ ಸೆಲ್ ಕೊಡೋ ಬದಲು ಏನ್ ಕೊಡ್ತಾರೆ, ಲೆಕ್ಲಾಂಚೆ ಸೆಲ್ ಅಂತ ಕೊಡ್ತಾರೆ. ಸೊ ಡೋಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ಲೆಕ್ಲಾಂಚೆ cell means they are talking about dry cell only. Fine. So in this cell, you can see here ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಇದೆ, ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಇದೆ. ಔಟ್ಸೈಡ್ ನೀವು ಸೆಲ್ ನೋಡಿದಿರಲ್ಲ, ಫ್ರಮ್ ಔಟ್ಸೈಡ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಆಲ್ವೇಸ್, ವಿ ಹ್ಯಾವ್ ನೆವರ್ ಸೀನ್ ವಾಟ್ ಇಸ್ ದೇರ್ ಇನ್ಸೈಡ್. ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಆಕರಿಂಗ್ ದೇರ್. Okay, fine. So you can see here anode consists of zinc container. This container what you are seeing, this particular container what you are seeing, this is my anode. And graphite rod surrounded by powdered MnO2 and carbon. Can you see here the paste of, okay, let me show it like this. So idu idenideyalla zinc, this is zinc rod, this acts as anode. This acts as anode. Okay, and the graphite rod what you are seeing here, which is surrounded by, iden nodta idiralla cream color du, this is all what it is, a paste of MnO2. We'll see why that paste is being taken. MnO2, zinc chloride, manganese dioxide, zinc chloride, ammonium chloride, and carbon. So this acts as, this graphite rod acts as cathode, and that is being surrounded by this paste. The space between the electrodes is filled with moist paste of NH4Cl and ZnCl2. So electrode reactions are complete. They are very complex. Idin reactions in agattala, they are very complex here, but approximationally we can show. Okay, so what are the reactions? Anode atra yen agatte, what do you expect at anode? Anox. So at anode we expect oxidation. Correct? So this is our memory tip. Starting linda ನೋಡ್ತಿದ್ವಿ from session 1. Cathode ಹತ್ರ ಏನಾಗುತ್ತಪ್ಪ, at the cathode reduction takes place. Red cat, yes or no? So reduction occurs. Oxidation ಅಂತಂದ್ರೆ ಏನು? Oil, that is loss of electrons. OIL, L stands for loss of electrons is at oxidation. Reduction, REG, so REG, gain of electrons. So this is all basics which we know. Fine. So with this basis, we'll see here. Anode yen tondidiri, you have taken zinc. So solid zinc will lose electrons and form Zn plus 2. Yes, and 2 electrons are lost. At cathode, those 2 electrons are being taken. Gain agattala. What is my cathode here? MnO2 is taken. Yes, so MnO2 along with NH4 plus ion, plus 2 electrons, it will form MnOOH hydroxide plus NH3 is, in the gaseous form it is liberated. In cathode, manganese is reduced from +4 state to +3 state. ನೀವು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ಸ್ ಮಾಡಿ ನೋಡಬಹುದು. ಮ್ಯಾಂಗನೀಸ್ ಇಸ್ ರೆಡ್ಯೂಸ್ಡ್ ಫ್ರಮ್ +4 state to +3. Actually see here, NH3 gas is not liberated actually as a gas, because it combines with this Zn plus 2 and forms ZnNH3 4 times 2 plus. This particular ion is formed. Okay, so ತೋರಿಸ್ಬೇಕಾದ್ರೆ we show it like this. ಅದಕ್ಕೆ ಹೇಳಿದೆ, actually this dry cell reaction is very complex ಅಂತ. Okay, so at cathode, Mn plus 4 is reduced to Mn plus 3. NH3 forms a soluble complex with Zn plus 2 as ZnNH3 4 plus 2. Okay, fine. So dry cells do not have you can say that dry cells do not have indefinite life ಅಂತ ಹೇಳ್ಬೋದು. In acidic NH4Cl, if acidic NH4Cl corrodes the zinc container, that becomes useless. Yes, acidic NH4Cl ಇದೆಯಲ್ಲ, if it corrodes the zinc container, useless ಆಗ್ಬಿಡತ್ತೆ. It is not in use. So dry cells have potential approximately 1 point cell potential ಎಷ್ಟಿದೆ? E cell potential. E cell, how much? EMF of the cell ಅನ್ಬೋದು 1.25 volt to 1.5 volts. So this is the approximation, the cell potential of dry cell. The new type of dry cell what we speak about, ನಾನು ಹೇಳಿದೆ, the improved version ಅಂತ ಅನ್ಬೋದು. The improved version of dry cell. So understood the construction and working of the dry cell, what actually happens at anode. Okay, so where it is being used? It is used in transistors and clocks. ನಾವಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಫೈನ್. ಓಕೆ, ಸೊ ದ ನ್ಯೂ ಟೈಪ್ ಆಫ್ ಡ್ರೈ ಸೆಲ್ ಈಸ್ ಮರ್ಕ್ಯೂರಿ ಸೆಲ್. ಸೊ ಮರ್ಕ್ಯೂರಿ ಅಂತ ಅಂದಿದ್ದಾರೆ ಅಂದ್ಮೇಲೆ ಸಮಥಿಂಗ್ ರಿಗಾರ್ಡಿಂಗ್ ಮರ್ಕ್ಯೂರಿ ಇಸ್ ಬಿಂಗ್ ಟೇಕನ್ ಅಂತ ಅನ್ಬೋದು. ಫೈನ್. ಸೊ ಮರ್ಕ್ಯೂರಿ ಸೆಲ್ ಅಲ್ಲಿ ಏನೇನಾಗುತ್ತೆ, ವಾಟ್ ಆಕ್ಚುಲಿ ಹ್ಯಾಪನ್ಸ್ ಅಟ್ ಮರ್ಕ್ಯೂರಿ ಸೆಲ್. ಸೊ ಹಿಯರ್ ಆಲ್ಸೋ ವಿ ಹ್ಯಾವ್ ಆನೋಡ್ ಅಂಡ್ ಕ್ಯಾಥೋಡ್. ಫೈನ್. ಸೊ ಇಲ್ಲಿ ಯು ಕ್ಯಾನ್ ಸಿ ದ ಪಿಕ್ಚರ್ ಆಫ್ ಮರ್ಕ್ಯೂರಿ ಸೆಲ್ ಹೌ ಇಟ್ ಇಸ್. ಇದನ್ನ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡೋದು ನೋಡಿದಿರಿ ಹೇಳ್ರಿ? ಇನ್ ಯೋರ್ ವಾಚಸ್ ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ದಿಸ್, ಎಸ್ ಆರ್ ನೋ? ಸೊ ವಾಚಸ್ ಅಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ಟೈಮ್ ದಿಸ್ ಇಸ್ ಬಿಂಗ್ ಯೂಸ್ಡ್. ಸೊ ದಿಸ್ ಇಸ್ ಮೈ ಮರ್ಕ್ಯೂರಿ ಸೆಲ್. ಸೊ ಮರ್ಕ್ಯೂರಿ ಸೆಲ್ ಅಲ್ಲಿ I can call this as, see, to be more peculiar, this mercury cell zinc amalgam, zinc mercury use ಮಾಡಿ in the form of amalgam. What do you mean by amalgam now? Whenever we talk about a combination of mercury with any other metal or a non-metal, ಮರ್ಕ್ಯೂರಿ ಇದ್ದಾಗ ಬೇರೆ ಮೆಟಲ್ ಜೊತೆ ಕಂಬೈನ್ಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಅಂತ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾಂಬಿನೇಷನ್ಗೆ ನಾವೇನಂತೀವಿ, ಅಮಲ್ಗಮ್ಸ್ ಅಂತೀವಿ. Usually we use these terms in alloys, right? Fine. So here you can see anode is my zinc mercury amalgam. Okay. Then cathode is what? Cathode is the paste of HgO, mercuric oxide and carbon. Fine. Electrolyte, idರಲ್ಲಿ electrolyte ಏನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ? What is the electrolyte used? It is moist paste of KOH and ZNO. This is being used. So what reactions occur at anode and cathode? Cathode reduction, quite obvious, gain of 2 electrons. So HgO in aqueous medium, H2O, it will take 2 electrons and forms Hg. This tells you what? This is the oxidation state of mercury. That is, and plus 2OH minus comes out. Fine. Anodic reaction, if you see, anode ಅಲ್ಲಿ ಏನಿದೆ, you have taken zinc amalgam. So Zn amalgam take to reacts with 2H minus. Anode ಅಂತಂದ್ರೆ reduction. Zinc will lose its 2 electrons. Then it will combine with oxygen and form zinc oxide plus H2O. If you write the overall reaction ಬರ್ದ್ವಿಯಪ್ಪ ಅಂತಂದ್ರೆ, or you can say the net reaction, if you see, we can represent it as Zn bracket Hg, zinc amalgam, plus HgO, ZnO plus Hg. Please look at the overall reaction. Since the overall reaction does not involve any ion, see here, can you see any ion here? ಯಾವುದಾದ್ರೂ charged ion ಇದೆನಾ? No, neither positive nor negative. So since the overall reaction does not include any ion whose solution can change, ion ಇದ್ದಲ್ಲಿ solution change ಆಗತ್ತಲ್ಲ, ಹೌದಲ್ಲ? So the cell shows constancy in the potential throughout its life. ಅಲ್ಲಿ ಯಾವುದು ion ಇಲ್ಲ ಅಂದಿದ್ದಕ್ಕೆ cell potential ಏನಿರ್ತದಲ್ಲ, throughout its life there will be constancy. Yes, and the cell potential is expected to be 1.35 volts. Yes, so you can see here, cell potential is constant during its life as the overall reaction does not involve any ion in the solution whose concentration does not change during its lifetime. So where it is being used? It is being used, ಹೇಳೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. If you, as soon as you look at the picture, you can tell where it is being used ಅಂತ, ಹೌದಾ? So it is being used in hearing aids, watches, calculators, ಎಕ್ಸೆಟ್ರಾ. ಅದು ರೌಂಡ್ ಆಗಿ ಸರ್ಕ್ಯುಲರ್ ಸ್ಟೀಲ್ ಕವರಿಂಗ್ ಇರುವಂತ ಸೆಲ್ ಇದು. ಎಸ್ ಆರ್ ನೋ? ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಇಟ್ ಮೆನಿ ಅ ಟೈಮ್ಸ್. Coming to the next concept, that is my secondary cells. So what is secondary cells? Secondary cells ಅಂತಂದ್ರೆ ಏನ್ ಹೇಳಿ? Just now we have discussed the secondary cells. They can be used again and again. If the battery comes down, again by passing current, by recharging it, what we say, again it becomes charged completely and we can use it again and again. So this is about secondary cells. So secondary cells ಅಲ್ಲಿ we have, this is better ಅಲ್ಲ, instead of dry cells. ಒಮ್ಮೆ dry cell dead ಆಗ್ಬಿಟ್ಟಂದ್ರೆ we have to replace it. But secondary cells ಹಾಗಲ್ಲ, you can use it again and again, but it is having certain life period also, right? Fine. So here we have the first secondary cell, that is lead storage battery. So secondary batteries. So what is most important secondary cell is the lead storage battery. It consists of lead as anode. So anode is what? Spongy lead. And what is cathode? It is the grid of lead packed with PbO2. See here. Lead is being PB plates idava. It is packed with spongy lead. This is my anode. And what is cathode? PB plate packed with PbO2 is my cathode. So this is cathode. You can see here these two plates, anode, This is cathode. Fine. Electrolyte is what? 38% H2SO4 by mass. So what is the electrolyte taken? 38% of sulfuric acid by mass is used as an electrolyte. Yes, idana ನೀವು you can draw it like this also, or you can take it in other form also. ಅಂದ್ರೆ ಒಂದು ಕಂಟೈನರ್ ತೋರಿಸ್ಬಿಟ್ಟು ನೀವು ಹೇಗೆ rectangular blocks ತೋರಿಸ್ತಿದ್ದೀರಲ್ಲ, for electrodes you can use it like that also. Okay, fine. So let us try to understand what happens. So you have here the cell reaction during discharging. When cell is in use, cell use ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ when you are using the battery, ಅದು ಹೇಗೆ discharge ಆಗ್ತಾ ಹೋಗುತ್ತಲ್ಲ, ಆ time ಅಲ್ಲಿ what is the reaction? When the cell discharges, it operates as voltaic cell. ಅಂದ್ರೆ lead is getting oxidized from, I can write here, Pb is getting oxidized from +2 ion, oxidized to +2 ion, and lead plates, Pb plates acquire negative charge. So anode reaction can be shown as Pb +2. At anode, I'll write it here, you can see. At anode, what happens? Pb oxidation, it is losing electrons and forming Pb +2. This Pb +2 combines with sulfate ions. Sulfuric acid ide. So adralli sulfate ions idava. So it combines with sulfuric acid of the sulfate ions of the solution to form insoluble lead sulfate. So Pb +2 combines with SO4 -2 to form PbSO4 insoluble. So you can see here, here is what we have, correct? So this is happening. This is anodic reaction. This is cathodic reaction. This is okay. So let us see now further what happens. Yes. Okay. We'll take it like this here. So at anode, what is happening? Pb loses electrons, forms Pb +2, and this Pb +2 combines with SO4 -2 of sulfuric acid to form insoluble, I'll show, precipitate of PbSO4, correct? Fine. So Pb plus, so this is precipitation reaction anta anbodu. So electrons given by Pb are used at cathode. So what happens at cathode? At cathode, PbO2, you have taken PbO2, right? And there is acidic solution, so H plus ions are there, will be taken by 2 electrons to form Pb +2 H2O. Yes, this Pb +2 combines with SO4 -2 to form PbSO4. This is also precipitation reaction. If you write overall reaction comes out to be Pb plus PbO2 plus 4H plus 2. I'm writing the balanced equation itself. Okay. 2 PbSO4 plus 2 H2O. So this is the overall reaction for lead storage battery. Yes. And the E cell, andre the cell potential is for lead storage battery, it is 2.041 volts. 2.041 volts. Yes. So it is clear that H2SO4 is used up during the reaction, during the discharge, and produced during the recharging. So recharging yavag agutte, again it will get produced. You charge madidaga, when potential is slightly greater than the potential of the battery is applied, the battery gets recharged. Recharge yavag agutte? Battery the potential kinta ಸ್ವಲ್ಪ ಜಾಸ್ತಿ potential ನೀವು apply ಮಾಡಿದಾಗ it gets recharged, and during recharging of the cell, what is happening? It is operated like an electrolytic cell. Discharging time ali, this is discharging reaction. Discharging time ali, it is operating as electrochemical cell, and during recharging time it is operating as electrolytic cell. So look at the beauty of this cell, electrolytic cell. So this should be known. So another secondary electrode, another secondary battery Yes, what we are talking about is nickel cadmium storage battery. So nickel cadmium storage battery, nickel cadmium storage cell nu anbodu. So what is my anode? Anode is cadmium. Okay. What is cathode? Metal grid containing NiO2. That is my cathode. Metal grid containing, see, you can see here, this is the picture. So anode is cadmium, cathode is metal grid containing NiO2. Okay, it gets converted like this during the reaction. We'll see that. And what is the electrolyte being taken? It is KOH solution. So anodic reaction ಏನಪ್ಪ? Anodic reaction ಬಂದ್ಬಿಟ್ಟು cadmium will lose 2 electrons. Yes, Cd plus 2 agutta. Plus 2 combines with oxygen, oxide ion, O minus 2, and forms cadmium oxide. Cathodic reaction, NiO2 with water and takes those 2 electrons. Yes, so NiOH twice plus 2 OH minus. Net reaction, overall reaction Cd plus NiO2 plus 2 H2O gives CdO plus NiOH twice plus H2O. Nickel cadmium cell has a longer life compared to lead storage battery. Yes, this is a better one anbodu, but what I'm saying here, this is quite costly. And where it is being used? It is used in camera flashlights. It is being used in camera flashlights. Okay, then you have something called fuel cells. Okay, what are fuel cells? Galvanic cells use fuel cells of combustion of fuel energy of combustion of fuels. ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಕಂಬಷನ್ ಆಗ್ತಿರ್ಬೋದು, ಮೀಥೇನ್ ಕಂಬಷನ್ ಆಗ್ತಿರ್ಬೋದು, ಆಲ್ಕೋಹಾಲ್ ಕಂಬಷನ್ ಆಗ್ತಿರ್ಬೋದು. ವಿ ನೋ ಆಕ್ಸಿಡೇಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಕಂಬಷನ್, ಬರ್ನಿಂಗ್ ಪ್ರೊಸೆಸ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಆಕ್ಸಿಜನ್ ಅಂತ ಅನ್ಬೋದು. ಸೊ ಅಲ್ಲಿ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುವಂತ ಫ್ಯೂಯಲ್ ಎನರ್ಜಿನ ತಗೊಂಡ್ಬಿಟ್ಟು that fuel energy is used as the electrical energy. Yes, in galvanic cells. Okay, so galvanic cells use fuel energy of combustion of fuels like H2 hydrogen, CH4 methane, CH3OH directly as a source to produce electrical energy. And here oxygen gas is used as an oxidizer. Oxygen gas is used as an oxidizer. So the fuel cells are pollution free and have high efficiency, more than 70%. Efficiency estiday, how much is the percentage? It is more than 70%. But very important is fuel cells you cannot use them. Teacher, efficiency 70% jalkita jasti ide. So electric vehicles bandidave ivaga. You can see electric bikes, electric cars, so many things are there. So better, instead of petrol you went for electricity. Why don't you go for fuel cells? H2O2 fuel cells use ಮಾಡಬಹುದಲ್ಲ. See, they are highly inflammable components ಅನ್ಬೋದು. They are highly inflammable. ಸ್ವಲ್ಪ ಸ್ಪಾರ್ಕ್ ಏನಾದ್ರೂ ಬಂದ್ಬಿಡ್ತಪ್ಪ ಇನ್ ದ ಮಷಿನ್ ರನ್ ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ, ಸ್ಪಾರ್ಕ್, ಲೀವ್ ಅಬೌಟ್ ಸ್ಪಾರ್ಕ್, ಮಷಿನ್ ಗೆಟ್ಸ್ ಹೀಟೆಡ್ ಬೈ ಯೂಸಿಂಗ್ ಜೂಲ್ಸ್ ಲಾ ಆಫ್ ಹೀಟಿಂಗ್ ಅಲ್ಲಿ ನೋಡಿದೀವಿ. ಇಟ್ ವಿಲ್ ಬಿ ಡೂಯಿಂಗ್ ವರ್ಕ್ ಅಂಡ್ some of the energy is used for heating up the component ಅಂತ. So if it gets heated up ಅಲ್ಲಿ immediate, since oxygen hydrogen is being used, hydrogen is inflammable, immediate it catches fire. So blast ಆಗೋ chances ಇರುತ್ತೆ. So highly corrosive chemicals they are. Yes, and costly no haudu, heavy no haudu. Therefore fuel cells don't find that much application. Where they are being used, space programmally these fuel cells are being used in space programs. Yeah, so let us study about these fuel cells now. So what happens? Hydrogen oxygen fuel cell. So electrodes, they are made up of porous graphite impregnated with catalyst. Which is the catalyst being used? Catalyst andre eno, which helps to speed up the reaction. Okay, so electrolyte is what? Aqueous solution of KOH or NaOH. Oxygen and hydrogen are constantly fed into the cell. So what is oxidation half reaction at anode? So oxidation half reaction bandbitu, you can see this is the setup. Okay, so this is the setup of hydrogen oxygen fuel cell. So here you can see this is being taken, hydrogen oxygen continuous flow there. This is my anode and this is my cathode. Yes, so here there are inlets. One is air inlet, another one is fuel inlet. Excess fuel horag bandbidutte, unused gases and water comes out. This is the outlet. So anode is my H2, cathode is my O2. Correct, please do remember this. Anode is my H2, cathode is my O2. At anode oxidation takes place, anox. So oxidation half reaction ಏನು, 2H2 plus 4OH minus gives 4H2O. 4 electrons are being lost. Reduction half cell occurs at cathode. So O2 plus 2H2 plus 4 electrons gives 4 OH minus. Overall reaction bandbittu, we will write formation of water actually ತೋರಿಸ್ದಂಗ ಆಗತ್ತೆ. So H2 plus O2 gives 2H2O. This is the overall net reaction ಅನ್ಬೋದು. EMF of this cell is, please do remember the EMFs. ಬಹಳ cells ಇಲ್ಲ ನಮ್ಮ ಹತ್ರ. We have hardly lead storage cell ಇದೆ. We are having nickel cadmium. This is one hydrogen oxygen fuel cell. Adradu EMF niಮಗೆ ಗೊತ್ತಿರಲಿ. So EMF of this cell is 1.0 volts. Thermodynamic efficiency of the fuel cell is denoted by nu. It is nothing but delta G upon delta H. Again, we come back to our concepts which we have studied in the previous classes. So delta G heng baritiri ನೀವು in terms of E cell ಬರಿಬೇಕಿತ್ತಂದ್ರೆ you write it as minus NF E cell. I had told you the beautiful nature of this particular reaction. ಏನ್ ಹೇಳುತ್ತೆ ಅದು calculation ಮಾಡ್ತೀವಿ, but what it says, if delta G is, if E cell is negative, delta G will be positive. Negative sign illide alla. Or I can say if delta G is negative, E cell will be positive. If delta G is positive, E cell will be negative. So delta G now we can write it like this, minus NF E cell, where N is number of electrons, then F is Faraday's constant 96,500 Henry or 96487 coulombs antana heli. Then E cell means what? It is the cell potential divided by delta H, enthalpy change, correct? So this is about hydrogen oxygen fuel cell. Now some of the applications of electrochemistry. So what are the applications of electrochemistry? Now nodidivi, we have already spoke about it. Let me recall it once again. Fine. So electrolytic refining of metals, for refining of very most least reactive metals ಅನ್ಬೋದು, because reactivity series ಅಲ್ಲಿ if you see, copper, Ag, Au all come at the bottom of the series, which say those elements are least reactive. ಹಂಗಿದ್ದಾಗ ಅದರದ್ದು ರಿಫೈನಿಂಗ್, ಇಂಪ್ಯೂರ್ ಕಾಪರ್ ಸಿಕ್ತಪ್ಪ ಅಂದ್ರೆ ಅದು ರಿಫೈನಿಂಗ್ ಹೇಗ್ ಮಾಡ್ತೀವಿ ನಾವು? ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್ ಅಲ್ಲಿ ನೋಡಿದೀವಿ. ಇಟ್ ಇಸ್ ಬಿಂಗ್ ಡನ್ ಬೈ electrolytic refining ಅಂತ ಹೇಳ್ತೀವಿ. So what is this? We have seen ಇಲ್ಲಿ ನಾವು impure, okay, so impure copper is taken as anode, pure copper is taken as cathode. Here you have a battery, negative terminal connected to cathode, therefore electrons ಬರುತ್ತೆ. Electrons ಬಂದಾಗ Cu plus 2, yes, Cu plus 2 from the solution, copper sulfate solution, they will go to the electrons. ಅವು electrons ಜೊತೆ attract ಆಗಿ they will take the electrons, they gain of electrons reduction ಆಗುತ್ತೆ, and they gets deposited on the cathode. ಆಮೇಲೆ ಈ ಕಡೆ ಏನಾಗ್ತಿದೆ anodic reaction ಅಲ್ಲಿ, copper which is there in this impure form, this copper, it is losing electrons. ಈ anode ಮೇಲೆ electrons ಕಳ್ಕೊತಿದೆ, loss of electrons is oxidation, and it is getting into the solution. Something like impure copper ಲಿಂದ Cu plus 2 ions solution al bartide, and from that solution Cu plus 2 ions are going on to the copper. So swalpa time aadmele you can see idu rod enagtide, it is becoming thinner and thinner, yes, and deposition illa agodrinda you can see the thickness of this cathode rod. Again, along with that impure copper rod ali Zn plus 2 ions and all also will be there. They will also come into the solution, yes, and they will get accumulated here. Ag, Au, they will get accumulated here, and that is called anode mud, anode mud or anode sludge it is called. So this is the application of electrochemistry. Even the second application of electrochemistry, electrolysis ali is my battery, sorry, is my electroplating technique. Electroplating is spoon ideyappa, any utensil I had told in the previous class, I want it to be covered with silver. So I will say I am having any breakfast with my silver spoon. Actually, it is not silver. It is a spoon of iron. Here it is shown. Steel spoon ide. Yes, but I want to have a coating of silver on it. So what I will do, I will take it as cathode. Same, apply the concept of electrolysis here. Cathode anta tagotini because cathode melene deposition agate. And silver spoon beka, take the as anode you take silver rod. Gold spoon beka, as anode you take gold rod. That's it. So copper spoon beka, take copper rod. Chrome spoon beka, take chromium. That's it. Anode anta change ಮಾಡಿ. And ಯಾವ rod ತಗೊಂಡಿದ್ದೀರಿ, ಯಾವುದು plating ಬೇಕು. For example, here silver rod I want, silver plating I want. So I have taken silver rod. ಅದರದೇ solution electrolyte ಆಗಿ ತಗೋಬೇಕು. So it will take AgNO3, silver nitrate. So what happens? Anode in the Ag electrons ಕಳ್ಕೊಂಡ್ಬಿಟ್ಟು it will come into the solution. Ag plus will see electrons here because battery See, potential in the electrons are coming here. Yes. So electrons will here electrons are there. So Ag plus negative charge get attract agate. So it will go and go on getting accumulated. And we have seen through Faraday's laws, ಎಷ್ಟು accumulation agate. How much current you are passing, that much accumulation occurs. So this is also an application of electrochemistry. Okay. The third application of electrochemistry is corrosion. So what is this corrosion now? Corrosion andre ಏನು? Yes. Corrosion you have studied from very low classes. ಅದರಲ್ಲಿ ಬಹಳ ಯೋಚನೆ ಮಾಡಿ ಆನ್ಸರ್ ಮಾಡುವಂತ ಏನು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇಲ್ಲ. Slowly when pure metals are being exposed to atmospheric air ಅಥವಾ ಕೆಲವೊಮ್ಮೆ acids ಗೆ expose ಆಯ್ತು, moisture ಗೆ expose ಆಯ್ತು ಅಂದ್ರೆ it gets eaten up by the atmospheric products, and that eating up of that particular metal is called as corrosion. Yes. So slow formation of undesirable oxidized compounds. ಅದು ಏನ್ ಫಾರ್ಮ್ ಆಗಿರುತ್ತೆ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಐ ವಿಲ್ ಗಿವ್ ಯು ದ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಈಸ್ ಮೈ ರಸ್ಟಿಂಗ್ ಆಫ್ ಐರನ್. ಇದು ಕೊರೋಜನೆ, ಬಟ್ ಫಾರ್ ಐರನ್ ಐ ಡೋಂಟ್ ಯೂಸ್ ದ ಟರ್ಮ್ ಕೊರೋಜನ್, ಐ ಯೂಸ್ ದ ಟರ್ಮ್ ರಸ್ಟಿಂಗ್. ಸಿ, ನೀವು ಐರನ್ ಅನ್ನ ತಗೊಂಡ್ಬಿಟ್ಟು ಇಫ್ ಯು ಹ್ಯಾವಿಂಗ್ ಪ್ಯೂರ್ ಐರನ್ ರಾಡ್ಸ್, ಯು ಕೀಪ್ ಇಟ್ ಔಟ್ಸೈಡ್. ಸೊ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಇಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಆಕ್ಸಿಜನ್ ನ ಇಟ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಆಕ್ಸಿಜನ್, ಇಟ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ಮಾಯಿಶ್ಚರ್. ಅಲ್ಲಿ ಆಸಿಡ್ಸ್ ಏನಿಲ್ಲ. ಸೊ ಕೆಲವೊಮ್ಮೆ ಆಸಿಡ್ಸ್ ಜೊತೆ ರಿಯಾಕ್ಷನ್ ಆಗೋ ಕಂಡೀಷನ್ಸ್ ಬೇರೆ, ಬಟ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಹಿಯರ್ ಕಾಮನ್ ಡೇ ಟು ಡೇ ವಾಟ್ ಎವರ್ ವಿ ಆರ್ ಸೀಯಿಂಗ್. ಸೊ ಆಫ್ಟರ್ ಸಮ್ ಡೇಸ್ ಇಟ್ ಇಸ್ ನಾಟ್, it doesn't happen in 1 or 2 days. It takes time getting. So it is a slow reaction, slow formation agate. So on that particular rod you can see some reddish brown powder you can see, right? A reddish brown powder eno, might be it is oxide. Iron alidre it will be oxide because it reacts with the atmospheric oxygen and moisture, and it forms this layer Fe2O3 XH2O. This layer is formed here, and this layer is in color reddish brown. ಇದಕ್ಕೆ ನಾವೇನ್ ಹೇಳ್ತೀವಿ? ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ರಸ್ಟ್. ತುಕ್ ಹಿಡಿದಿದೆ ಅಂತ ಹೇಳ್ತೀವಿ, ಯಾವುದೇನಿಲ್ಲ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ರಸ್ಟ್. ದಟ್ಸ್ ದ ರೀಸನ್ ಐರನ್ corrosion of iron is called rusting. Yes, now you can see here iron corrosion alli it is converting into what? Oxide. Adu omme rusting aitappa antandre it will lose its properties. Tensile strength kalkolutte, texture kalkolutte. You cannot use it for construction purposes and all. That is the harmful effects of rusting. Okay, fine. So oxide alli convert ಆಗ್ತಿದೆ. One more example you take copper utensils. ಸ್ವಲ್ಪ ಹೊತ್ತಿಗೆ what will happen? Copper utensils ಗೆ ಏನಾಗುತ್ತೆ ಹೇಳಿ? It will develop green layer. ನೋಡಿದಿರಿ? Green layer gets developed on copper. What is that green layer? That is the layer of carbonates. CuCO3, CuOH twice. Complex nature ide. So that is the layer of carbonates. ಅದಕ್ಕೆ ನೋಡಿ, and carbonates are basic in nature. ಬೇಸಿಕ್ ಇರೋದ್ರಿಂದ ನೀವು ಎಷ್ಟೇ ಸೋಪ್ ಹಚ್ಚಿದ್ರು ಅದು ಇಟ್ ವಿಲ್ ನಾಟ್ ಗೋ. ಸೊ ವಾಟ್ ಯು ವಿಲ್ ಡೂ? ನೀವು ಯು ಟೇಕ್ ಸಮ್ ಪೌಡರ್ ಕಾಲ್ಡ್ ಪಿತಾಂಬರ್ ಹಚ್ತೀರಿ. ಇಲ್ಲ ಅಂತಂದ್ರೆ ಯು ಯೂಸ್ lemon or pitambar. What is this? It is acid. So acid reacts with base, it neutralizes. ಅದಕ್ಕೆ ಆ ಕಲರ್ ಹೋಗ್ಬಿಡುತ್ತೆ. Understanding? So copper na ಬಹಳ ಹೊತ್ತು ನೀವು if you keep exposed to atmosphere, it gets coating of green. That is also corrosion. That is not rusting. Only for iron it is rusting. So illi oxide form agide, here carbonate is formed. Sometimes sulfide is formed. ಎಲ್ಲಿ ಅಪ್ಪ? Silver articles. ದೇವ್ರ ಐಡಲ್ಸ್ ಎಲ್ಲ ಸಿಲ್ವರ್ ಇರುತ್ತೆ, ಅಥವಾ ಗರ್ಲ್ಸ್ usually wear anklets which are silver, boys wear the chains which are silver. ಸ್ವಲ್ಪ ದಿವಸ you will see it has developed a coat. ಅದು ಎಷ್ಟು ಶೈನಿ ಇತ್ತು, so much lustrous it was, it will become dull ಅನ್ಬೋದು, ಅಥವಾ ಕೆಲವೊಮ್ಮೆ ಏನಾಗುತ್ತೆ it becomes black. Have you all seen that? Why? Because it reacts with atmospheric sulfur dioxide and it forms Ag2S. Sulfide it gets converted. See, that's what I'm trying to say here. So slow formation of undesirable oxidized compounds such as oxides, sulfides or carbonates at the surface of the metals by its reaction with moisture, oxygen and other atmospheric gases is known as corrosion. Yes, it is known as corrosion. So I have given you the examples here. Rusting of iron, Fe2O3 XH2O, reddish brown solid, it is called rust. CuOH twice, CuCO3, a green coating on copper metal, that is also corrosion. Aluminium, see, aluminium, the speciality ಏನಪ್ಪ, I'll just tell you here. Aluminium Al2O3 dirty white coating of aluminum on aluminum metal anta ಹೇಳ್ತೀವಿ. Actually the corrosion of aluminum, you know what I say, it is a protective corrosion actually. Why it is protective corrosion? Because see, aluminum foil na ಬಳಸ್ತೀವಿ ನಾವು. Why we use aluminum foil? ಎಲ್ಲಾದ್ರೂ ಹೋಗ್ತಿರ್ತೀವಿ ಟ್ರಿಪ್ಗೆ, we want to store our chapatis for few days. ಸೊ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಅಲ್ಯೂಮಿನಿಯಂ ಫಾಯಿಲ್ ಅಲ್ಲಿ ಅದನ್ನ ಮುಚ್ಚಿಟ್ಕೊಂಡ್ಬಿಟ್ಟು ಹೋಗ್ತೀವಿ. ಎಸ್ ಆರ್ ನೋ? ಅರೆ ಅಲ್ಯೂಮಿನಿಯಂ ಕೊರೋಜನ್ ಆಗತ್ತಂತ ಹೇಳ್ತೀರಿ, ದೆನ್ ಇಫ್ ಇಟ್ ಕೊರೋಡ್ಸ್, ಅದೇ ಮೊದಲು ಇಟ್ ಬಿಕಮ್ಸ್ ಅದು ವೇಸ್ಟ್ ಅಲ್ಲ, ಇಟ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಸ್ಪಾಯ್ಲಿಂಗ್ ಅವರ್ ಫುಡ್ ಅಲ್ಲ, ಬಟ್ ಸ್ಟಿಲ್ ವಿ ಯೂಸ್ ಇಟ್. ಅಲ್ಯೂಮಿನಿಯಂ ಫಾಯಿಲ್ ಎಷ್ಟು ಮಾರಾಟಕ್ಕೆ ಬರುತ್ತೆ ನೋಡಿದ್ರಿಲ್ಲ? ಬಿಕಾಸ್ ಯಾವಾಗ ಅಲ್ಯೂಮಿನಿಯಂ ಏರಿಗೆ ಎಕ್ಸ್ಪೋಸ್ ಆಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ಅಲ್ಯೂಮಿನಿಯಂ ಆಕ್ಸೈಡ್. ಅದರ ಆ ಅಲ್ಯೂಮಿನಿಯಂ ಮೆಟಲ್ ಮೇಲೆ, ಸೊ ದಿಸ್ ಇಸ್ ಮೈ ಮೆಟಲ್, ಅದರ ಮೇಲೆ ಲೇಯರ್ ಆಫ್ ಅಲ್ಯೂಮಿನಿಯಂ ಆಕ್ಸೈಡ್ ಇಸ್ ಫಾರ್ಮ್ಡ್, ವಿಚ್ ವಿಲ್ ಆಕ್ಟ್ ಆಸ್ ಅ ಪ್ರೊಟೆಕ್ಟಿವ್ ಕೋಟಿಂಗ್ ಫಾರ್ ಅಲ್ಯೂಮಿನಿಯಂ. ಅದನ್ನ ಫರ್ದರ್ ಕೊರೋಡ್ ಆಗಕ್ಕೆ ಬಿಡೋದಿಲ್ಲ. Therefore, that is being used for, it is called a protective corrosion and it is being used. Okay, it is having various applications anta anbodu. Okay, so what are the factors affecting corrosion now? Factors affecting corrosion alli reactivity of the metals. More reactive metals are corroded very easily than less reactive metals. Fine. Then presence of moisture and atmospheric gases like CO2, SO2, etc. The rate of corrosion increases. Presence of the impurities increases the rate of corrosion. I'm sorry, this is rate of corrosion. Okay. Strains in the metal surface helps water droplets to accumulate. ಯಾವ್ದಾದ್ರು metal ಮೇಲೆ marks ಬಿದ್ದಿದ್ವಪ್ಪ ಅಂತಂದ್ರೆ ಅಲ್ಲಿ water molecules go and get accumulated, where an electrochemical cell gets formed. That is also a factor. Presence of electrolyte helps to increase the rate of electrochemical reaction. Yes, so these are the factors affecting my corrosion. Now how to prevent? So you can see here rusting of iron is an example given. Electrochemical theory ಒಳಗೆ ಮಾತಾಡ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ corrosion of iron is called rusting of iron. Electrochemical cell, also known as corrosion cell, is developed at the stains of iron. So you can see here, so anode is nothing but my pure iron and cathode is impure Fe surface. This is my rust, reddish brown powder containing dissolved air in water droplets. So electrolyte CO2 plus H2O, H2CO3 form agutte, H plus CO3 minus 2, this becomes my electrolyte. Anode reaction, loss of electrons, Fe will lose 2 electrons and form Fe plus 2. So this is anodic side, Fe plus 2. So it is losing 2 electrons. You can see here, losing 2 electrons. Okay, Fe plus 2 aitu. Cathodic reaction, oxygen from the atmosphere, it takes that H plus ion, electrolyte linda, and the 4 electrons and forms H2O. Okay, cathodic reaction, and the standard reduction potentials are given. For reduction potential haudalva, because plus 2 ion is written first, so reduction potential is minus 0.44 volt. For cathode it is 1.23. Okay, what will be the net reaction? So here you can see Fe plus 4H plus O2 gives 2 Fe plus 2 to H2O. The E naught of cell, standard cell potential is 1.67 volt. So surface ಏನಾಗ್ತಿದೆ 2 Fe plus 2 plus 4 H2O plus O2. See, atmospheric water, oxygen, it is forming Fe2O3. XH2O combines with extra molecules of water. This is my rust. This is my reddish brown powder called rust. So further production of ions continues the rusting process. It continues the rusting process. So this is about rusting of iron. Rusting of iron. So hope the concepts are clear. Concepts clear agidavanta ankoltini. So here let us take some numericals regarding E cell. Okay. So rusting of iron yavag agatta, when rusting anta yavag term use marti. Even I'll tell you one more we have. Yenappa antandre, we have a term called rancidity. Rancidity anta andre, you know what is rancidity actually? Rancidity is also nothing but corrosion only. But corrosion of metal anta ಹೇಳ್ತೀವಿ ನಾವು. Rancidity is corrosion of metal. Okay, fine. So let me give you one numerical here. So I'll say resistivity mele we will see the numerical. Fine. So this is the numerical on resistivity. Electrical resistivity, electrical resistance of column of 0.05 moles per liter NaOH solution of diameter 1 centimeter and length of 50 centimeter is 5.55 into 10 raised to 3 ohm. Okay. Calculate its resistivity, conductivity, and also molar conductivity. Molar conductivity. So this is my first numerical based on the concepts what we have discussed: resistivity, conductivity, and molar conductivity. Okay, so how do you do this? Tell me. So here, what is given paila nodi? So given here is, I'll write it here. Resistance is equal to resistance is equal to 5 point ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ಹೇಳಿ 5.55 into 10 raised to 10 raised to 3 ohm. Correct. What is the further what is given? Length ಕೊಟ್ಟಿದ್ದಾರೆ. What is length? Length is 50 centimeter. Then diameter is given. So diameter is 1 centimeter. I want to find the area. Area ಬೇಕಲ್ಲ ನನಗೆ. So I'll take radius ಎಷ್ಟಾಯ್ತು? Half centimeter is the radius. ಅಥವಾ ಅದನ್ನ 0.5 centimeter ಅಂತಾನು ಬರಿಬಹುದು. So what is area? Area is equal to pi r square. So what is the value of pi? I'll keep it as it is only. Pi 1/2 square centimeter square. Correct? So this is my area. Fine. So what is being asked to find? You are supposed to find resistivity. You are supposed to find conductivity, that is kappa, and molar conductivity. Ella omme sikbittappa ಒಂದು numerical ಅಲ್ಲಿ ಎಲ್ಲ ನೋಡ್ಕೊಂಡ್ಬಿಡೋಣ. So we know that R is equal to what? Rho into L by A. So using this, can I find rho resistivity? So rho is equal to R into A by L. Is that right? So substitute the values. 5.55 into 10 raised to 3 into what is area? Pi value is to 3.142 or 3.14 into 0.5. Half under 0.5. The whole square, right? Divided by how much? Length. How much it is? 50 centimeter. I'll keep all in centimeters only because yellatra centimeter kotidara, that is not an issue for us. Okay, fine. So R value, when you solve it out, R value comes out to be 87. Sorry, rho value comes out to be 87. I'm sorry, rho value of rho. So rho ಎಷ್ಟು ಬರುತ್ತೆ? It is 87.135 ohm centimeter. Yes, unit of rho is resistivity is ohm centimeter. Ohm meter baritivi. Here, since all the terms are in centimeter, so this is my first answer. Now, what is the second question being asked? Second question is kappa. And what is kappa? Kappa is nothing but 1 by rho. Substitute 1 by 87.135. Solve it out and tell me how much value you get. You do it. ಇದನ್ನ ನಾನು ಮಾಡೋದು ಹೇಗೆ ಅಂತ ಹೇಳ್ಕೊಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ ಅಂತ ಅನ್ಕೋತೀನಿ. You get 0.0114548 Simon centimeter inverse. Yes. And last thing what is being asked is molar conductivity. What is molar conductivity? Kappa by concentration. Correct. So how much concentration is given? See, 0.05 moles per liter. But I want it in moles per cc. Centimeter idella. So convert it. How you will convert? Concentration will be 0.05 by 1000 moles per cc. Right? Correct. So substitute molar conductivity. Molar conductivity is 0.01148 by 0.05 by 1000. Is that right? By 1000. So solve it out and see how much answer you get. When you solve it, how much answer? How much do you get? that will be your molar conductivity. Correct? So this is how you are going to find the molar conductivity or resistivity or ಯಾವುದೇ ಕೇಳಿ, if you know the formula and proper substitution. But sometimes factors ಇದು ಏನು conversion factors become very important, whether it is being asked in centimeter ಅಲ್ಲಿ ಕೊಟ್ಟು ಮೀಟರ್ ಒಳಗೆ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ find the answers in this particular unit ಅಂತ ಕೇಳಿದಾಗ you need to be very careful of how to do the conversion factors, otherwise it is very easy ಅಂತ ಹೇಳ್ಬೋದು. Okay, shall we take another one? So I'll give you conductivity of 0.20 molar solution of KCl at 298 Kelvin is 0.0248 Simon centimeters inverse. Calculate its molar conductivity. So how do you do it? How do you do? Okay, what is given, nodi, substitute it and put the proper formula. So what is being asked? You are supposed to calculate molar conductivity. Okay, and I know the formula for molar conductivity is what? Kappa by C. Correct? So what is my kappa? So 0.0248 by 0.20 molarity. Conductivity is given 0.02 molar. This is my concentration. So concentration in the form of molarity. M, capital M stands for molarity. I want, see, since kappa is in the form of Simon centimeter inverse, I want molarity in Simon centimeter inverse irodrinda, centimeter inverse irodrinda, molarity andre enu? Moles per liter. I want it in moles per centimeter. Correct? Moles per cubic centimeter. Howda? So I can have the factor of 1000 here. So how I'll write? Molar conductivity is equal to 0.0248 divided by 0.20 by 1000. So I can write it like this: 0.0248 into 1000 by 0.20. Solve it out. You will get the answer 124 Simon centimeter square per mole. Just look at the concept. It is clear or no? Nodkolli. So you will get the answer so much. Is that right? You can see here. Look at the SI unit for molar conductivity. Molar conductivity to SI unit nodkond bidi. So actually when we'll be using regular agi Simon centimeter square anta use madiddivi. You can see, you might be knowing that. So you should be knowing how to convert the units also. Okay, now write Nernst equation and EMF of following cell at 298 Kelvin. Okay, the third one. Cell given is Sn solid bar Sn plus 2. Equation, question on Nernst equation: 0.050 molarity, double bar H plus 0.030 molarity, bar H2 gas, 1 bar pressure, comma, platinum solid, inert electrode. Fine. So you are supposed to write the Nernst equation. Nernst equation baribeku anta andre, we should be knowing the oxidation half and the reduction half. Or we'll write the overall reaction first. So Sn, and we have She here. This is a standard hydrogen electrode. Howda? So Sn plus H plus togolana. So here we have Sn becomes Sn plus 2 plus H2. Okay, H2 andaga I'll balance it by writing like this. Now see which is Sn from Sn solid, it is becoming +2. So yaudidu loss of electrons, oxidation, this will occur at anode. H plus, it is becoming H2 by gaining the electrons. Gain of electrons is reduction. This will happen at cathode. H2 we know. Okay. So what is the, let us solve it out. Okay, fine. So what is the formula for standard cell potential? Because at 298 Kelvin andidara, 1 bar pressure is there. Okay. So Nernst equation ಯಾವಾಗ ಬರುತ್ತೆ ಟೀಚರ್? at concentration 1 molar ಇರಬೇಕಲ್ಲ? No, at any concentration ಇದ್ದಾಗನೇ Nernst equation ಬರುತ್ತೆ. Yes or no? At any concentration we get Nernst equation. E naught cathode minus E naught anode. Fine. And I know my cathode and anode. Which is my cathode? She is my cathode. Standard hydrogen electrode, to be more specific, H plus bar H2 minus E naught. Reduction potentials we are talking about. Fine. And this is Sn plus 2 bar Sn, right? What is the SRP of she? She SRP is 2. Standard reduction potential of C is 0, minus. And from the electrochemical series, the value standard reduction potential of Sn plus 2 bar Sn is minus 0.14. So you will get E naught cell as 0.14 volt plus 0.14 volt. Fine. Okay. So next, what you are going to do? E cell bekala namge. Using Nernst equation, we want E cell. So Nernst equation, we will write the equation and then we'll calculate E cell. Fine. So Nernst equation, we'll write it as, what is number of electrons? Tell me here. Number of electrons. It is 2. Sn is becoming plus 2, losing 2 electrons. So it is 2. Fine. So Nernst equation is E cell, E naught cell is equal to E cell minus 0.059 bar n log, natural log illa, log will take concentration of Sn plus 2 by concentration of H plus. Numerically product ion concentration, denominatorly reactant ion concentration. Okay. So ಇಲ್ಲಿ ನಮಗ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ? What is given? Sn plus 2 concentration ಕೊಟ್ಟಿದ್ದಾರೆ. How much it is? 0.050 molarity. And what is the concentration of H plus? Concentration of H plus is 0.030 molarity. Substitute all the values. So E cell, let's calculate. E cell is equal to 0.14. E naught cell na il substitute madidine. I've taken this side. Okay. Minus 0.059 divided by 2 log 0.05 by 0.02. I'm sorry, this is 0.02. Okay. 0.02 the whole square. Solve it out. Check how much you get. You should get the answer 0.078 volts. 0.078 volts. So this is another example of how we represent a Nernst equation ಹೇಗೆ ಬರಿತೀವಿ, and using that how we can find the EMF. ನಾವು ಹೇಳಿದ್ ನೋಡಿದ್ವಿ, we had seen the applications of Nernst equation. Find the EMF, equilibrium constant ನೋಡ್ತೀವಿ. All these things we have seen, yes or no? So using that we can solve the examples ಅಂತಾನು ಅನ್ಬೋದು. So here we have one more problem. Let's take the last one. Calculate standard cell potential, or I'll write E naught cell of a galvanic cell in which the reaction is given 2 Cr solid plus 3 Cd plus 2 aqueous gives 2 Cr plus 3 aqueous plus 3 Cd. So this is the reaction. Calculate E naught cell. So how do you do that? So E naught cell calculate madodidena. So this is Cr2 plus 3 oxidation anode and Cd plus 2 to Cd reduction cathode. Ishtu gottidre saku. So here the reduction potentials of Cr plus 3, this is minus 0.74 volt. This is ESRP. Okay, ESRP. And for this SRP value is minus 0.40 volt. Okay, so let us see. E naught cell is what? E naught cathode minus E naught anode. Okay, so what is E naught? Standard reduction potential of cathode. Cathode is minus 0.40 minus 0.74. Solve it out, you get 0.34. So this is my E naught cell. Now E naught cell calculate madi, then calculate. Okay, continue. The problem continues. You have to calculate delta G. Yes, then equilibrium constant Kc you need to find. So how do I calculate delta G? Delta G naught I'll take. Yes, standard conditions ali, that is equal to minus NF E naught cell. So what is my N here? See, plus 3. So minus 3. How many electrons here? 2 into 3. I'm sorry, it is 6. Yakantandre 3 electrons are there, 2 ions. So 6 into 96487 into how much answer you have got? 0.34. Solve it out, you will get minus 196.87 kilojoules per mole. So this is my delta G naught. Third one is Kc. See, at equilibrium, what is E naught? E cell. E cell value at equilibrium is 0. So use the formula. E naught cell is equal to 0 ide E cell. So therefore E naught cell ikkade shift madidini. 2.303 RT by NF log Kc, because I want to find equilibrium constant. So E naught cell can be written as minus delta G naught by NF 2.303 RT by NF log Kc. Even NF gets cancelled. So I can find, lastly I can write it as log Kc is equal to 2.303 RT delta G naught. And I know the value of delta G naught, 2.303 RT. Delta G naught value, how much I've got? R substitute madi, gas constant. T you substitute, and delta G naught is minus 196.87. Substitute this, you will get the answer 34.496. This is log Kc. If you want to find Kc, you take anti-log of 34.496. You will get the answer. You will get the answer of equilibrium constant. So this was all about electrochemistry and some of the applications in electrochemistry, some of the numericals, some of the examples. Hope in these 5 sessions, all the concepts were crystal clear. Hope there are no doubts. Even if you have doubts, you can text me or you can message me, chat in the chat box. So study well. All the best for your coming years. Thank you.